Imagine it's a dark and stormy night. You're lost in the woods. You sense there's something chasing you. You start to run, but you trip over a fallen branch. You turn over and look behind you, and there, in a flash of lightning, is this, f of x. Wait, hold on. You don't have to be afraid of functions. I know, they look scary. Where'd that f come from, and what does it mean? And why is it holding that x prisoner? Functions have intimidated math students for as long as there have been bad stories that start with it being a dark and stormy night. But in this lesson, we're going to see that functions are just like any other equation. And, in fact, it's very simple to make a graph of a function. First, let's get a few things straight. A function is a rule that uses an input to produce an output. Let's say you see f of x equals 2x. That just means that for each value of our input x, our function f produces an output of 2x. So if we input 5, our output is 5 times 2, or 10. If we input 7, our output is 7 times 2, or 14. So f of x equals 2x is actually similar to y equals 2x. Again, if x equals 5, y equals 10. In this equation, y is a function of x. The value of x determines the value of y. Now we can get into graphs. The graph of a function is a visual representation of all of the points on the plane of x, f of x. Note that f of x is taking the place of y in that ordered pair. This graph we're making is just a collection of points. You know that famous painting by Seurat? The one that looks like a normal picture, but when you look closer, you see that's really a collection of countless tiny dots. A line on the graph is the same thing. It's just an infinite number of dots. To graph a function, we take that idea and follow a simple three-step plan. Let's try this out with this function. F of x equals 3x minus 4. Okay, let's start. Step 1. Find ordered pairs. Your ordered pairs are your dots. If you can find an infinite number of them, you'd have your graph. But we don't have time for that here, though that could be a fun project. We're just going to fill in this chart. In the x column, let's pick some numbers. It doesn't matter too much what we pick, but we want to make sure that if this line curves, we check enough numbers to notice that. Let's use -1, 0, 1, and 2. To find the ordered pairs, we plug our x values into the function. Start with -1. Just plug that into our function. F of -1 equals 3 times -1 minus 4. So our f of x value here is -7. Let's add that to our chart. That means our first ordered pair is -1, -7. 0 is next. F of 0 equals 3 times 0 minus 4. That's just -4. Next is 1. F of 1 equals 3 times 1 minus 4. That's going to be -1. Finally, there's 2. F of 2 equals 3 times 2 minus 4. That'll be 2. Okay, we have our points. Now comes step 2, plot the points. Let's move over to the coordinate plane and plot those ordered pairs. Here's -1, -7, and then here's 0, -4. If you know you have a straight line, you really only need 2 points, but we're being cautious and plotting 4 points. So here's 1, -1, and here's 2, 2. That leaves our final step. Step 3, connect the dots. You probably practiced this in preschool. Did you know then that connecting the dots would be a practical skill in advanced math? Anyway, before we connect the dots, let's make sure we know what they're doing. Some functions have curves. You'd be able to tell because a straight line wouldn't go through all of our points. But if we draw a line here, it does. So we have our line. And this is the graph of f of x equals 3x minus 4. Now that we know the 3 steps, let's get some practice. First, let's try f of x equals -3x plus 6. Remember step 1? Find ordered pairs. Let's make a chart. Okay, now pick some values for x. How about we try even numbers? -2, 0, 2, and 4. Next, plug them into our function. F of -2 equals -3 times -2 plus 6. That'll be 12. F of 0 equals -3 times 0 plus 6. That's just 6. F of 2 equals -3 times 2 plus 6. That's going to be 0. Finally, f of 4 equals -3 times 4 plus 6. That's negative 6. I'm noticing a pattern here. Okay, step 2, plot the points. Here's negative 2, 12. Here's 0, 6. Here's 2, 0. And here's 4, negative 6. Finally, step 3, connect the dots. This one is definitely a straight line. And here it is. This is the graph of f of x equals negative 3x plus 6. Let's do a trickier one. F of x equals x squared plus 2. Okay, step 1, find ordered pairs. Since x is squared, let's make sure we use both positive and negative numbers. Let's use negative 4, negative 2, 2, and 4. So what's f of negative 4? F of negative 4 equals negative 4 squared plus 2. That's 18. Next is negative 2. F of negative 2 equals negative 2 squared plus 2. That's 6. Then 2. F of 2 equals 2 squared plus 2. That's also 6. And since we're squaring x, we know that 4 will be the same as negative 4, or 18. Now step 2, plot the points. Okay, here's negative 4, 18. Here's negative 2, 6. Here's 2, 6. And here's 4, 18. Finally, we connect the dots. Now you can probably tell that this isn't going to be a straight line. This line curves. We can see it curves up here and also up here, but how do we know where it starts? That will be the smallest possible value of y. Since we're squaring x, the smallest y value will be when x is 0. Why? As we saw, when we square a negative number, we get a positive number. Therefore, every negative x value will give us a larger y value than 0. So let's check what y is when x equals 0. F of 0 equals 0 squared plus 2. It's 2. So that's the bottom of our graph, 0, 2. If we connect the dots, we get a parabola. This example is a good reminder that you can always try more points if you're not sure what the graph will be. Just like that painting, sometimes you need a lot of dots to be sure. Hopefully, you don't need as many as Seurat, though. In summary, when we want to graph a function, we want to make a visual representation of all of the points on the plane of x, f of x. We follow 3 simple steps. Step 1, find ordered pairs. Find as many as you want, though I recommend at least 4 or 5. Step 2, plot the points. See what they look like on the graph. Then step 3, connect the dots. Channel your inner preschooler and graph your function.